So we continue from the previous video. We have found the mean, which is 0.22, and the standard error, which is 0.0239. So I'm going to take that to StatCrunch. So in StatCrunch, I have the mean 0.22 and the standard deviation 0.0239 based on the values we have earlier. So I want greater than or equal to 0.25, and I will adjust that. Greater than or equal to 0.25 and compute. So take note, greater than or equal to that, and you have 0.1047. Okay, that is our answer there, 0.1047. Then for the next part of the question, what is the probability, capital P, that in a random sample of 300 adults, between 20% and 25% of the sample proportion do not own a credit card? This is same as probability of between 0.20 P at 0.25, that is equal to, let's use the same distribution, 0.22, 0.0239, and I am interested in between 0.20 and 0.25. I will look at the size of the probability between them, and let's see. So going to StatCrunch, I need to change my interface to between 0.20 and 0.25, which I happen to accidentally already have. So I have the parameters there, compute, and you have 0.69395. That will be 6940 to 4 decimal places. So my answer here is equal to 0.6940. Then for part D, would it be unusual for a random sample of 300 adults to result in 60 or fewer who do not own a credit card? Probability, the proportion who do not have a credit card is equal to 60 out of how many? 300, or fewer, that means or lesser. So this is equal to probability of P at less than or equal to 60 divided by 300 is 0.2. So in the context of this distribution, we have the mean still at 0.22. The standard error is still this, but we are now looking at the number in relation to the number 0.20. We'd like to look at the region below it. So let's see. So in this case, I'll go back to StatCrunch, go to the standard interface, change this to less than or equal to, and 0.020, and compute. In this case, I have 0.2013. So this region is equal to 0.2013. When is an event unusual? It is if the probability is lesser than 0.05. In this case, the probability we have just obtained for this event is greater than 0.05. So it is not unusual at all, since the probability is not lesser than 0.05. Now that we have completed this question, we proceed to some application problems. Example, according to a study conducted by an organization, the proportion of Americans who were afraid to fly in the year 2006 was 0.10. A random sample of 1,300 Americans resulted in 143 indicating that they are afraid to fly. Explain why this is not, statistically speaking, necessarily evidence that the proportion of Americans who are afraid to fly, originally it was said to be 10%, has increased. How do we do this? This is a very good way to see how what we are learning can be used to ascertain or check claims in the real world. The first thing is to make a check. First of all, we note that the sample size that is taken in order to check is 1,300. Take note that we need to check if this is less than or equal to 5% of the entire population. Well, the entire population is all Americans. 1,300 is definitely less than 5% of the entire population of Americans, who are about 300 million. So that first condition is met. Condition 2, we need to check if NP times 1 minus P is greater than 10. N in this case is 1,300. The hypothesized population proportion is 10%, and then 1 minus 10% is exactly 90%, or 0.90. This will be equal to 117, which is definitely greater than 10. Since these two conditions are met, well, we can say that the distribution of P hat is approximately having the normal distribution. It's approximately normal with the mean of P hat equals to exactly P. Our P in this case is the proportion, P 0.10, and the standard deviation of P hat is the square root of P 1 minus P all over N. That will be the square root of 0.10, 0.90, which is 1 minus 10%, divided by N. Our N is 1,300. And this is equal to 0.00832. Since we are using the normal distribution, we need to determine, to answer this question, we need to determine if this observation, of 143 in 1,300 is unusual. That is, we need to determine if the probability of P hat equal to 143 out of 1,300. Take note, if 143 out of 1,300 is unusual, then anything greater than 143 out of 1,300 is also unusual. So we need to determine if this value is unusual. How do we check that? We're going to find the probability, the probability that P hat is greater than or equal to 143 over 100, and check if it is lesser than 5%. In other words, step 1 will be, let's focus on probability of P hat greater than or equal to 143 divided by 1,300 is 0.11. Using the normal distribution that we said we can use earlier, we will need the center. The center is 0.10. The measure of spread is 0.00832. And we are concerned with the probability related to 0.11. And we want to look at the region above, at that value or above. And using StatCrunch, we need to key in the mean and the standard error. Let's do that. So here I am in StatCrunch. I'm keying in the mean and the standard error, and I am interested in the probability greater than or equal to 0.11. So I will key in that, greater than or equal to 0.11, and enter. So I have 0.114696 or 1147. So let me take that back. This region is 0.114696 1147. What do we observe? This probability is definitely greater than 0.05. So this is greater than 0.05. If this probability were lesser than 0.05, we would say that it is unusual. But since this probability is not greater than 0.05, the event of 143 in 1300 1300, indicating that they are afraid to fly, is not unusual. If it is not unusual, that means that the initial assumption that the proportion is 10% has not changed. We don't have any suspicion to say, oh, we observe something unusual. So that means we are now suspectful, or we are now suspicious about this population proportion. We did not observe anything unusual, so this proportion has definitely not changed. It has not increased, it has not changed at all. That is what we can imply. So if it has not changed, this analysis tells us that what we observed in this sample does not give us any evidence, any substantial evidence to say that the proportion of Americans who are afraid to fly has increased. With this said, we can proceed then to question 25. This says that exit polling is a popular technique used to determine the outcome of an election prior to results being tallied. Suppose a referendum to increase funding for education is on the ballot in a large town, which has a voting population of over 100,000. An exit poll of 200 voters, so this is your sample size, finds that out of that sample, X equals 104 voted for the referendum to increase funding for education. Question A, how likely are the results of your sample if the population proportion of voters in the town in favor of the referendum is 0.49? What this is asking is as follows. If the population proportion, P, is 0.49, we need to find the probability of fewer than the 104 out of 200 who voted for the referendum. Who voted for the referendum? Okay, to do that, first we have to go through our usual checks. We check if N, which is 200 voters, if it is less than 5% of the entire population. The entire population, if we put a lower bound of 100,000, well, 5% of 100,000 at the lowest is equal to 5,000. So 200 is less than this. That condition is met. Condition 2 is to check if 1 times n times p times 1 minus p, that will be 200 times 0.49 times 0.51, which is 49.98. This is also greater than 10. The second condition is met. So we can definitely use the normal distribution. If we're using the normal distribution, we need the mean of P at, which will be exactly equal to the P, 0.49. We also need the standard error, which will be P times 1 minus P all over N. This would be equal to the square root of our P is 0.49. 1 minus 0.49 is 0.51 divided by N. N is 200. And this will be equal to 0.035348. Now, with the two parameters that we have, the mean and the standard error, we're going to take that to StatCrunch. So let me go to StatCrunch, and here I am in StatCrunch. I'll go to the mean. The mean in this case, as we found earlier, is 0.49, the actual population proportion, and the standard error is 0.035348. And in particular, we want to find the probability of fewer than 104. That is, we want to find the probability that the sample proportion is less than or equal to 104 out of 200. So this is a proportion that P at is less than or equal to 0.52, which, going back 0.52, that will be somewhere here, and we're interested in the area below it, 0.52. So let's go to StatCrunch, less than or equal to 0.52, and compute. We have 0.801977. So we have 0.802. 0.802. Okay, if that is the case, then at this point, one thing we immediately observe, based on this result, we can say the following. Based on this result, we can comment on the dangers of using only exit polling to call elections. This is a statement to note. The comment here is as follows. Since the probability of 0.802 is greater than the probability of an unusual event, which is 5% in this context, the event is not considered an unusual event. What that translates to mean is that it is not unusual for one to experience, all right, let me adjust that, for one to experience a wrong call being made in an election if exit polling results alone is all that is being considered. This is very important to note when we're considering election results. Very, very important. With that, we come to the end of this topic.